Okay, let's start the surface chemistry. Surface chemistry deals with the phenomenon that occurs as surface or interface. Interface or surface boundary that separate two bulk present in the large amount. Surface or intense is represented by separating the bulk phases by a happen or a slash, for example solid gas or solid gas, solid slash gas. The bulk phase that we come across in surface chemistry may be pure compounds or solutions. Now we have solid gas. Now what we have is solid slash gas, liquid slash gas. So surface interface. There is no interface between gases due to complete miscibility. The surface or interface is normally a few molecules thick. Its area depends on the size of the particles or bulk phase. After that we have applications. So electrochemical equilibrium at solid liquid interface. Corrosion is an example that everybody can understand. So adsorption, now we have the topic starts with adsorption. Solid surface has tendency to attract and retain other phase particles. Such particles remain at surface without moving deep into the bulk. From here we can easily understand that if you are dividing a solid piece of any block into more fine pieces, you will find its surface area will increase in the fine pieces. So it is the accumulation of molecular species at the surface. It is generally the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid. Adsorption. Two types of substances are involved in adsorption. First one is adsorbate, second is adsorbent. So this is important to notice here, adsorbate and adsorbent. Adsorbate means it is the molecular species or substance that concentrates or accumulate at the surface, and in adsorbent the material on the surface of which the adsorption takes place. So this acts as a surface area to take adsorption. So the material on the surface of which the adsorption takes place is called adsorbent and adsorbate. It is the molecular species or substance that concentrates or accumulates at the surface. It's very nicely shown in the image. The next part of adsorption. Adsorption is easily a surface phenomenon. Solids, particularly in finely divided state, have large surface area. Therefore, charcoal, silica gel, alumina gel, clay, etc. act as a good adsorbent. We can remember charcoal, silica gel, alumina gel, etc. act as a good adsorbents. Now, for example, we have gases like oxygen, hydrogen, carbon monoxide, chlorine gas, ammonia gas, sulfur dioxide gas are taken in a closed vessel containing charcoal. The air becomes dry in the presence of silica gel. The air becomes dry in the presence of silica gel. Good thing. Now, what is desorption? The opposite of adsorption is simple desorption. In desorption, what takes place? The process of removing an adsorbed substance, adsorbate from a surface on which it is adsorbed. Adsorbent. Okay. The process of removing an adsorbed substance, adsorbate, from a surface on which it is absorbed, adsorbent. Surface is adsorbent and the substance is adsorbate. Now what we have the example, anhydrous CaCl2, calcium chloride. The phenomenon in which the particles of gas or liquid gets uniformly distributed throughout the body of the solid. The phenomenon in which the particles of gas or liquid get uniformly distributed throughout the body of the surface. It's a simple thing. The phenomenon in which the particles of a gas or liquid get uniformly distributed throughout the body of the solid. Example is calcium chloride and hydrous calcium chloride. Absorption. Now we have the difference between the absorption and adsorption. Absorption, all thing together we have the substance is uniformly distributed throughout the bulk of the solid. The concentration is uniformly throughout the bulk of the material. Like that we यहाँ से हम वीडियोस बना सकते हैं.